I know y'all saw that. All right, so we are reviewing notes, composition of functions. Okay, we've done this before. How do I know that? Because literally in Algebra 2, I just finished this section. So I know that we did this section. We also did like a little whole scavenger hunt in the hallway for this section. So when you act brand new while doing this, I'm gonna say I wasn't your teacher. Okay. I'm gonna say I wasn't your teacher then because and only one person can say I wasn't their teacher. So the rest of y'all, I'm just disowning you at that point. That's what it comes down to. Huh? I know, isn't that a cute? I was like, oh, that's a cute little setting. Okay, now back to normal. All right. So first off, we're going to start off with basic evaluation review. So I want you to take a moment and to evaluate. Okay, evaluate the following function using f of 5, f of c, f of 4a, and f of 5x minus 1. So start here and go.
Roberto, you will not believe
Evaluate. What day is your last one? February 21st. I do that. That's about I'm sacrificing my birthday for life and sugar.
Yep.
And so much for going out of town.
It's on Bird. It's true.
Wow. I can do it. Don't worry. I'm evaluating. I had to do it. Sometimes I'm like, Bridget, you don't vote for X and single life.
Oh, that's it?
I never did.
Okay. Yeah, I think I got it. How could you forget? I just woke up from the nap. I'm like, oh,
I can't use the calculator. You shouldn't need a calculator. Like you did. I hate teachers that think you have to.
Wait, you're not supposed to be looking.
I know, but I'm trying to see him.
Oh, you did. Oh, you did. Oh, I see it. Oh, you're so smart.
All right.
Smart.
All right, here we go. So evaluating. Starting off with f of 5. That means I'm plugging in 5 for x, right? Simple enough. So where there's an x, it becomes a 5. So we have f of 5 equals 2 times 5 minus 3, which gives us 10 minus 3, which is 7. So f of 5 equals 7. F of c, I'm just replacing one variable with another variable. So you should just have 2c minus 3. Okay. On f of 4a, it's not just a variable, but it's a number and a variable. And they're both replacing the x. So we have 2 times 4a minus 3, which leaves us with 8a minus 3. Yes? Yeah. Last, we have 2 terms now replacing x. Oh my gosh, 2 terms. So that gives us 2 times 5x minus 1 minus 3. What do I need to do? Distribute 10x minus 2 minus 3, which gives us 10x minus 5. If you can do this, can you compose? Yeah. Really? Maybe? Yes, we can. Yeah. All right, so let's review composing. Okay, composite functions. Sometimes in math, we plug a value in for x. That is a function. That's all it is. It's plugging a value in for x that is a function. All right. The answer is just another function that is simplified. Does that make sense? Because I'm producing another function, that means that the domain and range has also changed. Okay. And that's called composite function. Okay. All right. So do we remember there are 2 ways that we can write a composite function? So there are 2 ways we can write a composite function. Do you guys remember seeing F composed of G? Y'all remember that? Okay. That's fog and goth. The other way is we can see it as F composed of G of X. F of G of X. So either F composed of G of X or F of G of X. Composed. Okay, we read these expressions as F composed of, F of X composed of G of X. Okay, when we are reading this, when working the composite function, we start on the inside. Work our way out. Okay. Now, if it's in this form. If it's in the other form, we start from the right. Okay. So you're going to evaluate, in this case, we're going to evaluate G of X first. And we're going to use the answer from G of X and plug it into F of X. Okay. Can F and G be called anything else? Yes, they can, because functions can have different names, right? It could be H, it could be K, it could be anything. What matters is the order that they're in, right? Okay. All right. Are we remembering this? I know the person who taught it to you. So here we go. We have F of G of 3. F of G of 3. And again, when it's written in this form, we're working our way from the inside to the out. So we got to do the inside first. So we have G of 3 to evaluate. So we're going to evaluate G of 3. And that's going to give us 7. Make sense? 2 times, do I need to write it out? We're inside G of X. So 2 times 3 plus 1. And that gives us 7. What you get from G, you now are going to plug it into F. So now we're looking for F of 7. So that gives us 3 times 7 minus 5. Now we have 21 minus 5, which is, so our answer is 16. Okay, I'm going to stop. You're now going to do B and C and check with your neighbor. Now you're doing B and C. Remember, we start from the inside and work our way out.
I'm really distracting my learning experience. Some more chit chat. Aren't you adding chit chat? Why do I hear you?
Let me know if you need me. I'm not paid the big bucks, but I am paid some bucks to help. Got it. We're doing stuff Okay, I'll take that. People are working, right? Hey, Jeff, how are you? Who's checking your neighbor? Who are my neighbors? I'm not your neighbor, Hudson's your neighbor.
Sure.
16?
You're welcome, neighbors.
I don't hear it.
I got 576.
All right. All right, let's see how we did. Okay, what did you guys get f of 3? 4. Then what did you do with the 4? Plug it into G. And what'd you get? G of 4. 9. So our final answer is 9. All right. Does it change just because I'm using the same function? No. So we start from the inside. What did you guys get for f of 4? And then we took that and we plugged it in. We got 16. And we really don't have to think too hard because we already did it once. All right. Yes. We're good there? No questions, comments, or concerns? Okay, cool. Now, what if I'm not evaluating, but I'm just composing and creating equations? Is that going to change anything? No, it doesn't. All you're doing now is what we did on the very first example, where you plugged in that 5x minus 1. That's what we're doing here, right? We're now plugging in an equation instead of a number in. So, someone remind me, what is f of x? From our example 2. 2x plus 1. And what is g of x?
Wait.
3x minus 5.
Yeah.
Did I write? Yeah. I was like, well, no, I was going to let you make it. All right. Try again. What's f of x?
3x minus 5.
And what is g of x? There we go. All right. So we're now, our inside is just x. And because it's just x, we're evaluating the function. So we are replacing g of x into f. We're substituting it in, right? So first thing we're going to do is substitute in g of x. What is g of x? 2x plus 1. That means inside of f, all my x's become 2x plus 1. So we end up with 3 times 2x plus 1 minus 5. Do not forget the terms that are already there. Don't forget any terms, any coefficients that already exist, okay? So we keep going and we get 6x plus 3 minus 5, which leaves us with 6x minus 2. Yes? All right, now go ahead and do B. This time you have G composed of f of x. So G composed of f of x. What do you get?
This could be what our test is over.
Part of it, yeah.
That's like,
What we
I think
did.
there's 80% of the test.
We just glazed over, and then we have 2%.
like the negative one.
Oh, that's the last piece. Our test is actually on Tuesday.
Why did you years long?
Our test is Tuesday.
You better.
By two.
We have a 4-day weekend. We don't have
You know,
school.
we're 3 here basically. Like,
So that would be 3
you
days.
rate so well that you should know that you think
You just got
Anyways.
myself-
Those people cool, right? All right, let's keep it going. Okay, you have a 3-day weekend. All right, so our inside is f of x. And f of x equals 3x minus 5. So that means where x is in 3 and g of x, I'm going to replace it with 3x minus 5. So we're left with 2 times 3x minus 5 plus 1. So don't forget those outside terms already. So we get 6x minus 10 plus 1, which means our final equation is 6x. How do we feel? Yes. Amazing. Oh, sorry. Okay. All right. Now, are all functions just going to be linear? No. And we're not only using linear functions. Oh no. Okay. All functions will not be linear functions. So keeping that in mind, you need to remember your other functions matter and that your other functions have restrictions as well. Okay. So for example, if I have a square root function, what is not allowed underneath my square root? A negative. So if I had a negative input, would that work initially? No, it would not. So I couldn't even go any further. So you have to remember some of those properties. If I had a rational function, what can your denominator not equal? 0. So then I couldn't plug in values that would make my denominator equal to 0. If you have if that function is square root, then it's going to stay square root. All right. So really quick, we're going to go through these fairly quickly. Is that okay? If I pick up the pace? Yes. All right. Here we go. So we're doing h of 2. So when I look here for h of 2, I know that h of 2 equals what? What is that? So that is 1. H of 2 is 1. Agree? Now I'm going to go to K and I'm going to plug 1 into K. So when I plug 1 into K, I am left with 1 squared plus 4 times 1 plus 5. And we get what? And we get, say that again? Say that again? Say that again? 10.
Wait.
I was hoping you were going to fix it. I kept hope alive. All right. 1 plus 4 is 5. 5 plus 5 is 10. Okay. I know you were forgetting. All right. Let's speed it up again. This time we're in composition form instead of in function notation. This means that I am starting from the right. So I'm going to take -1 and plug it into m. Okay. What is m of -1?
-3x.
It's -1. If I plug -1 into m, I get -1. Agreed? Now I take that result and I plug it into h. So now I'm looking for h of -1. What is h of -1? -5. So my final output is -5. Okay. Now here, again, working from the right, we're going to evaluate x and p, which is just simply p of x. And p of x is square root of 3x minus square root of 3x plus 1. So I'm taking that and I'm plugging it into k. So everywhere that there's an x, it now becomes p of x. Do we see that? Just thinking your glasses are on top of your head. Plus 4 times the square root of 3x plus 1 plus 5. What happens when you square a square root? It gets rid of it. It sets it free. Fly, little birdie. Okay. Can I do anything here? I can't do nothing. It's just 4 the square root of 3x plus 1 plus 5. All right. Keep evaluating. Combine like terms. What are my like terms? 1 and 5. So we now have 3x plus 6 plus 4 square root of 3x plus 1. And you can't simplify. There's nothing else you can do. I can't combine any more like terms. I can't reduce anything. This is where you stop, and that is okay. Okay? There is a stopping point. It may look weird. You may be like, oh, I can do some more. There is nothing left to do, friends. Okay? Cool? Are we good with nonlinear composition?
Where'd you go back to him?
Already there. Come on, Pearson.
I love it. Okay.
I realized that I didn't have it where you can viewable, but it should be viewable now. If not, I think Hudson, was it viewable now? The homework?
Any questions?
15.
Oh, that's not bad. Yeah. Stop it there.
All right, here we go. So this time we have, what kind of graph is this called? What is this called? Anybody? It's a piecewise. It's in pieces, right? It's a graph made up of pieces. It's a piecewise function. All right. We have a graphical piecewise function, which is f of x. And then we have a function notation, an equation of piecewise function. And then here we have a verbal description. It says k of x is a quadratic function with a horizontal translation of 2, followed by a vertical translation of -3. Okay, so that means I have to now write what k of x is as an equation. So k of x equals what? I am a quadratic function with a horizontal translation of 2, followed by a vertical translation of -3.
Wait, which one are you using?
You're going to be using all three.
Wait, we're doing it by code.
Right now, we're just creating it. I just want to make sure we're all. Oh, my table didn't come. Dang it. I don't have my table. Do you have your table, Regina? Okay. Where's my table? I'm missing my table. Yes.
Oh.
All right. So it says our quadratic function. So first thing first is translated 2 units. That means that this has to be x minus 2 because horizontal translations are connected to your x, right? And our x's are liars. So we don't write it as plus 2. We write it as minus 2. This is quadratic, so this isn't singular. It is squared, correct? These are things that we have to remember, okay? Translated -3, that means on the outside, after I do this, I'm going to shift down 3 units. That is our function. Do we see that? Yes. Okay, you need to be comfortable with that. I have no clue why I don't have my G. We're not creating anything. We're just gonna write it. Okay, but you guys are just gonna have to tell me what G is because I don't have my table. My table got cut off. All right, what's my x values for G? -4, -1, 2, 5, 7, and what are my y values? 4. All right, thank you. All right, so now we're evaluating. We have all the ways that we can represent a function, and now we're going to use composition in all these ways, okay? Up first, we have G of 3. G of 3 means that I'm using which model first? I'm using I do the inside first, so G of 3, which one of these models is it referring to? The table, Miss Jones, because that's what the table is called. The table is called G of X. Do you see how your output says G of X? That's the table's name. So what does that mean? If I don't have anything here, guess what that means? Not possible, no solution. If it's not on something that's given to you, if it's not part of your discrete data, then you don't have it.
Basically, if you're telling us if we get a question and it's not based on anything on the paper, we just say no solution.
Hence the model.
I'm gonna do that next time there's something on the test that we haven't done.
That's not what I said at all, Hudson. That's not at all what I said to you, but okay, get it wrong. All right. Why did I put no solution here though? There's no 3 on the G of X, right? And this is a discrete data. So like they're giving me information here and there's nothing I can do with it. Make sense? Okay. So therefore there is no solution. All right. Now go on to B. Can I do B? So I start from the right. Is there an f of 8? If I go to the piecewise graph, I go to 8. What do I get? -1. So there is an f of 8. So f of 8 equals -1. Now I'm going to take that and plug it into h. So h of -1. Now you're using a piecewise equation. Using a piecewise equation, you have to pay attention to your inequalities. Which line of the piecewise am I using? Why the first one? Exactly, because -1 is less than 1. So I'm using the first equation to evaluate -1. Does that make sense? So we have the absolute value of -7 plus 3 times -1. And what does that equal? +10. So my final answer is 10.
What's that saying?
Okay. Okay, here we go. So 0, we're evaluating it from k. K is our quadratic that we wrote into an equation, correct? Okay, so we're looking for k of 0. You can evaluate because G is a discrete data. That means I'm giving specific points to look at.
Right, we don't have the. Hold on.
I'm not there yet.
Then let's get there.
We are.
I'm kidding.
I was like, we are. Easy killer. Okay, good job. All right, -2 squared is 4, and 4 minus 3 is 1. So now I'm evaluating at G of 1. Oh no, what do you notice? Why is it no solution? It doesn't have 1. There isn't 1 on our discrete data set. Okay, so do you see the two ways that you can end up with no solution while composing? Yes? Any questions so far? All right. Your turn. Let's see how you do. Yes. It's composed. Means you're plugging in and plugging in and plugging in. So when you get to this one, how many times you got to plug in? Okay. All right, go. Excuse the fact